Hello, everyone. Welcome to this last episode of the first season of Swift Academy. Today, for this special episode, I'm very glad to be with two special developers that come, I think, from Germany and also Netherlands, from Chris and Florian from Germany. And they come from Objective-C.eu, which is a famous website that I think a lot of developers, iOS developer and Apple developers, if we can say, know about this great content, great video, a lot of talks, video about iOS development, a high level. In their video, also they are the writer of, I think, many books about app architecture, SwiftUI, core data, etc. And today I'm very glad to be with Chris Eidhof and Florian Kugler from Objective-C.eu. How are you, Chris and Florian?
I'm doing really well. Thank you. Thank you for having us, and thank you for such a nice introduction.
Yes, thank you.
Yeah, thank you.
Thank you,
I'm glad to be here.
Yes, it's a special episode. That's why I know that I will take some time with you to speak about Objective-C.eu and also SwiftUI Animation. And my first section, we can speak about, first of all, Objective-C.eu. I think that the story came in 2012, if I'm not wrong. And the project, it's basically after this, I think 12 years now. How do you think about this experience? Every week you have a new video, I think, and with a great content, with a high level. How you can keep this consistently in your work to keep every week a great content to the community?
So I think, first of all, we have to apologize for this horrible domain name. As you noticed, Objective-C. Nobody knows how to pronounce it. And we just came up with it together with Daniel back then, sitting in a cafe close to my house, and we were thinking of how to call it. And Objective-C was the language back then. So we just chose this shortcut, Objective-C.io, and it's kind of a horrible domain today, but we just stuck to it. So sorry for that.
Yeah, I think
sorry
for the content, I think from the outside maybe it looks more impressive than from the inside. There's not everything is great, and but those are often the things that work well. Those are often the things that people will share more. So I think the perceived greatness is much higher than the actual quality. But no, and maybe one thing, so we started with the magazine, I think, in 2013. And one thing that really helped there is Florian and me, when we started, we had basically very little deep knowledge, but Daniel had a lot deeper knowledge about the whole ecosystem. And but we had a lot more time, and so the combination was really great because we could spend a long time writing articles, and then Daniel would say no, this is all wrong. And we would go back and rewrite it, and we had the time. And I think the other thing that sort of helped a lot was we immediately had Natalie on board, who's been our copy editor ever since, still until today, and she really helped improve the language so that we can actually get the point across. And I think, and then Jurian was there in the beginning to help with the design, and that also really I think made a big difference, right? Like the way you present that, and I think it's just a sort of a happy coincidence. And then we immediately had all these really great guest writers, and all of that sort of set the bar very high by accident from the first issue, so it sort of happened by accident.
I would also add that we have done a lot of different things over the years. So it's not like we have put out consistently some sort of a video since 2013 or something like that. So we started just with the magazine, and that was really just a project of love, basically, you know. So there was no money involved, and everybody, all the people from the community, just did it for, I don't know, for the joy of doing it, basically, you know. Nobody got paid. And then
Yes.
after a while, we took the opportunity when Swift came out to write our first book. And then we wrote another book. And so we delved into this realm for a little bit. And then we started with the videos, and then we started workshops. And so there were many different things that we did over the years. We also developed some products in between. So yeah, that's maybe it's not a single focus consistency over 12 years. It has been quite a few things that we've worked on.
Okay, great. I think it takes times for you to have this consistently, and by the time everything it's growing, it's everything with the feedback of the community also. And what I think in your website or so in your books is the quality of I think the high level. How you can explain that in 2011, sorry, you have this level of in Objective C or so in Swift. What kind of your daily learning? Because when you find your content, we think that we have a very deep between the level of the community, the large level of the community, and your levels and other developers. What kind of daily learning that you practice to have this quality of video, etc. Because I think that you have first of all a high level in Swift and also in Objective C. How you can explain, maybe to make some tips and tricks to the community, how you your process of learning that you come to this level, because honestly maybe after 10 years, 20 years, we cannot have the same level. I think that it's the process of learning and what you focus when you check Swift language, etc. That impact after that your video. And what do you think about I don't know, about SwiftUI animation, about how to create EDSL, embedded domain specific language, about how you're thinking about SwiftUI? You have a book about thinking SwiftUI. It's another because people, they try to have SwiftUI technology. Okay, we have some animation, we have some component, but you're thinking about declarative things, about how SwiftUI it's created under the hood.
Maybe I can share two stories, and then Florian, you can share some more.
Okay.
So when we started working together at the very beginning, even before Objective-C.io, I was hired by Florian's former company to pair program with Florian, who was one of the founders, and I was hired as an expert Objective-C developer, and Florian was a really good programmer, but zero experience in Objective-C. I think it was zero or close to zero.
Yes.
And so we would work together, and then he asked me like, okay, so why are you using frames and not this new auto layout thing that I read about? I said, yeah, no, I don't really trust that, and it's too new. And then the next day, actually, Florian would come back and say like, yeah, so I dove into this, and so me as the expert, I was being taught by the beginner, and so that mentality, I think, has stuck with us ever since, where it's sort of, yeah, the curiosity, you just want to know, and you try to explain to each other what you learned. And yeah, it's just, for me, I don't know if I can speak for both of us, I think so. Like, I just want to know how this stuff works. I want to understand it. And maybe the other story there is that we were trying to investigate how SwiftUI works a little bit, and we wanted to write a book about it maybe. And it was just weird, because there was this modifier frame, max width infinity, min width something, and what do these things do, and how does this actually work, and like, how do the parameters correspond to the output at all? We couldn't make sense of it. And that's where at some point we started putting pieces together in sort of doing very basic re-implementations of some of the layout parts, right? Like, so how would you re-implement the frame max width infinity modifier or the max width at all? And so by doing more and more of these basic re-implementations, we sort of, it made so much sense, because the way you would write that in the end is still weird code, but you get the same results, and then you can analyze that and then sort of get closer and closer to the real thing. And I think in general there, the one thing we do a lot is try to re-implement stuff, which is super time consuming, but then if you know how to implement something, you understand it well. I think at least that's the case for me.
Okay.
Yes. So maybe two things about that. So I think I agree that we both share this curiosity of wanting to know how things work. You know, I think we are both not satisfied with just googling some solution and putting it in and not caring about why it works. You know, so I think we share that. And then so the other thing is that we were very fortunate over the years, so that we were able to, like, out of this whole magazine thing basically that we started back then writing our first book, and out of this entire process basically, that we were able to have the time at our hands to do these kind of things, you know. So that was basically the good fortune that we had, and basically, so up until today, I think we have a pretty specialized knowledge that is pretty deep about specific things, and we don't know much at all about many other parts of the iOS ecosystem. You know, so basically, we had the time at our hands because we basically could make our living doing that, investigating, writing, making videos, stuff like that. But our focus always also has been pretty narrow. So we focused a lot on Swift when it came out, on this new language. We focused a lot on SwiftUI, but just the core part, right? The basic mechanisms. How does SwiftUI works? So we focused a lot on that. But there are so many other things that a real quote unquote iOS developer needs to do in a real job that we are not very good at. Right. So I think that's also important to keep in mind, that it's a narrow focus and the time that we have.
Okay. We have, for example, we have, like, I don't know if we even have team skills, right? Like, it's just the two of us, and like, in a real job, most people need to communicate with other stakeholders. They need to communicate with the designers. They need to get CI working, and like make sure you get through App Store review, and deal with complicated architectures. And we basically, it feels almost like we're building toy project after toy project, and it never gets super complicated. And if it does, we know why it's complicated and that we need to fix that at some point.
Okay. Yeah. Great. I think it's a special experience that you have both since this number of years, and you face it now with the growing of Objective-C.eu, some challenges. What kind of challenges now that you face it? And maybe we have some perspective that you try to make both in the future to this great project, which is Objective-C.eu.
So I would say we were very fortunate in this regard. We didn't face many challenges. We many opportunities came our way, I'd say, much more than challenges we faced. So of course we had, for example, like when we started Swift Talk, which was not clear at all in the beginning, what this should be, how it should work. You know, it was a new medium for us. So we learned about that, and we tried to work our way into this new way of communicating things. But that was fun to do, actually. You know, and so I would say most of the time we were very fortunate that this whole Objective-C.io story was more about opportunities that came our way, and not so much about challenges. Like, because also I think very consciously kept it a small operation all the time. So we didn't have the growing pains, of hiring many people and stuff like that. So yeah, I don't know. Chris, do you know any challenges?
Yeah, maybe like one challenge would be that we are so small, right? So at some point we had this really good idea. I still really enjoy the idea of building like some kind of static site generator done well, as a complete contained Mac app and all of that. And I think we spent like more than half a year on this, during which we could still record Swift Talk episodes, but not much else. We could basically keep that running, but that's it. And a lot of episodes actually fell out from the experience of building that thing. But then at some point we decided, yeah, this is getting too complicated. Like the more we work on it, the more complicated it gets instead of the more finished. And so maybe that's a challenge that we face, that we wanted to like, as Florian mentioned, deliberately stay lean.
Yes.
And then you can only do so many things, right? Like there's a pretty clear limit to how much you can do when it's just two people.
Yes. It's opportunity instead of challenges, if
Yes.
we can. Yes. Okay, it's great about Objective-C.io. We can go to the main topic, which is to speak about SwiftUI animation. And maybe we can, for people that never use it before SwiftUI animation, speak about some basic things about especially your experience with SwiftUI animation. There is a lot, I think it's series, and to speak about particle effects, etc. In Objective-C.io. But before that, from people that come from UIKit, and there is also animation in UIKit, what the main things, the main key difference that you can find between UIKit animation and SwiftUI animation?
Yeah, I think in UIKit, the animations are imperative, so you add an animation to something mostly. I mean, there are so many different animation systems. I lost track because we haven't done any UIKit for years now. But at least it used to be the case that you would just add an animation to something and the animation would run and then it would complete. And in SwiftUI, you don't really get access to that imperative system. So you can say, well, I want this view to animate whenever something changes, and that's about all the control you get. And so that's a very different thing, because you need to do, you don't start an animation in SwiftUI. You say, well, I have this view before and I have this view like after the state change, and I also have a state change. And then when that state change happens, I want to animate between the before and the after state. And so that's a very different mental model. And the weird thing is that you can, in many cases, you can just add a dot animation in your view tree somewhere and it will magically work. And when I saw this announced, I was very skeptical. I did not like it because it felt like magic, like the wrong kind of magic, right? The magic that you don't understand. And so one of the first things we actually did is try to build some more animations that felt like pushing what the limits are, and that very quickly, like we wanted to do all the animations that we were able to do in UIKit, and that quickly taught us a lot about the animation system.
Yeah, and it's also a long process of learning about that, right? I don't know how many years ago is this now? Like multiple years, 4 years? I have no idea. Since we started this, and we are still learning how this works with animations, and but generally, it's like with almost everything. When you look at the differences between UIKit and SwiftUI, unfortunately, you can basically just throw away almost everything you know about UIKit development, because SwiftUI has nothing to do with that. It's just entirely different. Of course, you know what a timing curve is, and perhaps this kind of stuff. So that carries over. But basically, that's the. I think that the transition from UIKit to SwiftUI is a much, much harsher one than the one from Objective-C to Swift, because there are many concepts carried over. and we got some new ones and stuff like that. But with SwiftUI, it's just clean slate, like forget everything. And that's pretty. We see that in the workshops a lot. That this is very hard on people, and sometimes people who have never done or are very new to the Apple ecosystem. It's much easier for them to get started than for experienced UIKit developers.
Okay, and for my point of view, I began only with SwiftUI animation. I didn't have any experience with UIKit animation, and I think that difference it's especially with the declarative approach, which very with much less in code, lines of code comparing. But in consideration of performance, what do you think about comparing using SwiftUI, comparing to UIKit, or using especially for, I don't know, maybe for simple application. I don't speak about complex application, because I think that there is some issues maybe for only SwiftUI animation with this. But from simple application, I find that there is some consideration performance. What do you think about in your workshop, in your video, about performance in SwiftUI animation comparing to UIKit?
I think you can achieve anything you want. Maybe one so just recently on SwiftTalk we did we implemented a particle system, and that was super low level. So we used timeline view which is kind of like a CA display link, and then we use canvas, which is kind of like a CG context. It's not quite the same, but you can do immediate mode drawing tied to the refresh rate of the display, and we did not have any significant performance problems there, and we had lots of particles on the screen. It's very doable. And then you can go all the way to the declarative animations, where you literally just add a dot animation somewhere, and there it works as well. But I think you do have to understand, unfortunately, like how that works and what's happening, because it can be easier to come up with weird animations that don't really work the way you think they should, and maybe they're glitchy. But often I think it's not necessarily a performance problem, but more just a mistake in the code. What do you think, Florian?
Yeah, good question. So we've never really had issues with things where we thought, okay, we cannot make this work because of performance. We are running much more into problems that where we think, well, how do we make this work with SwiftUI at all? Like especially in the beginning, how do you make this animation work? Performance with animations was never a big problem for us. That doesn't mean that it's not there, right? Because it totally depends on what you're trying to achieve. But for us, we never really ran into serious issues there.
Yes.
Maybe one thing to add also is that a while ago, I think on Mastodon, there was a bit of a thread going back and forth about measuring a basic animation in SwiftUI and seeing that it used, like, I don't know, if it was 80% CPU or 20%, at least compared to core animation, that was using 0% CPU. And I was a little bit worried about that as well. We tried to replicate, and we saw some interesting things. So the moment you have, for example, a custom animatable property, which we could talk about in a minute if we have the time, it runs code on a main thread. And so that will that's one thing that happens, where maybe also performance could be influenced. And the other thing is that apparently, if you making that comparison between SwiftUI animations and core animation just by looking at the CPU usage is not quite a fair comparison, because core animation apparently runs out of process where SwiftUI animations don't. I don't know the exact details of this, but that's our current understanding, that it's hard to really compare the two just by looking at CPU usage.
Okay. And okay, because when I think there is some application that I I use it and I think about the animation. There is a lot of animation. I don't know, maybe the Waze application with some animation when you are traveling, etc. And there is animation that appears, and you think about performance and how things working with SwiftUI. There is a lot of animation that appears and disappears. There's a lot of information, and you think about performance with SwiftUI, and that's why I thought about this question. Maybe there is another tools to check the performance, not only the CPU, and that's come to some I think challenge for developers that come to maybe to have some knowledge about fundamentals in SwiftUI. This kind of what we call explicit and implicit animation, because there is some theoretical things, explicit animation, and there is a lot of types of animation: spray animation, spring animation, keyframes animation. There is also the famous protocol animatable, etc. And people that come, what do you think they should maybe learn from the documentation? Maybe also see your video and other videos, or this kind of roadmap how to begin with animation. You should maybe have some knowledge about implicit, explicit animation, or begin by what?
So I would say, sorry, Chris,
No,
I'll
go
just
ahead.
give a preamble, then you can continue. So I would say you have to probably take a step further back, because to understand animations in SwiftUI, it's important first to understand how you build view trees in SwiftUI,
Okay.
and how the state system works in SwiftUI. So so in our book Thinking in SwiftUI, we try to outline these basic elements, right? And it seems very basic, but that's really important and builds on top of each other to understand how you build view trees in SwiftUI, because in contrast to UIKit, it's implicit and not explicit, right? In UIKit, you say add subview, and it's immediately clear to you that you are building a tree. And in SwiftUI, it isn't. And if you cannot basically in your mind expand your code into the tree, then many things in SwiftUI will be hard to understand. And so I think that's with animations, it's the same thing. It's really important to well, perhaps this is all clear to you, perfect, then we can go ahead with animations. But oftentimes what we see in the workshops, also why we spend so much time on these fundamentals, is that it's not straightforward for people to see how you actually build up these views in SwiftUI.
Yeah, I think the trees are sort of the underlying model, or at least our underlying mental model. And if you don't have a similar underlying model, you can just poke at it and use the dot animation, and maybe it works, but you never really understand why and how. And at least that was our experience from ourselves, right? Like not understanding how things work. And the moment we sort of formed that model and refined it and found mistakes in our mental model and improved it, I think it got much clearer. So for the simple stuff that we do, I feel like I can explain almost everything, why it works or why it doesn't work. At the moment I look at somebody else's project, it's too complicated for me and I don't understand it anymore. But maybe, I don't know, maybe we can have this is a good time to have a look at some example
Okay.
animations.
Yes, maybe you can.
Florian, do you want to do some typing? Should I do some typing?
I can start doing some typing.
Okay, great.
Okay.
And then probably you will have to take over at some point, because maybe my Xcode doesn't do what I want it to do. We'll see. So let's see. It worked well in our testing. So let's see if it still works.
Yes.
Okay. So you see my Xcode window, right?
Yes.
Okay. Okay. So this is basically just our project template, with a VStack and an image and a text. And let's perhaps simplify that a little bit to start with. So let's just start with the text. And so the interesting part about SwiftUI is that when you compose these views, so for example, in this case, a very simple view, just a text, then what you're getting behind the scenes is also a tree of views, but it's not obvious what it is because you never say add subview or something like that. And so we can try out a different approach of visualizing that. And what we did always is doing something like that. We write an extension for that on the view protocol and create some sort of a method. You can call it debug or whatever you feel like, and just return some view. And then in here, what we can do is we can actually inspect the type of the view, because in SwiftUI, everything is hidden behind these opaque return types. It always just says some view, because otherwise the type would be way too complicated to type or to understand. But we can print that. So we could do something like print type of self, type of self, and then we return self. So basically we don't do anything to the view hierarchy, we just print the type. And then here we can say .debug. And so now when I launch that, let me see, there probably there it still works. So great. You don't see the window which I launched, but you don't have to, because it's just about the console printout. So this is simple, right? It just says text. And so we can see that the text view is hiding behind this opaque return type, some view. And then when we add something here, so for example, we can add a padding and then launch this again, then we should see a different output. So now it's a modified content of a text and a padding layout.
Okay.
And so this is already getting a bit weird, right? What are these things? Modified content, padding layout. And it turns out that this is basically just saying the original view that we had, the text view, is getting wrapped in a padding view. Okay. That's basically what modified content of text and padding layout tells us. So we got a super view around the text, right? So .padding is actually the super view of text. And so this is already kind of counterintuitive, that you have to parse this from the bottom up when you write view modifier .syntax, right? .padding, .foreground color, whatever. You have to start reading from the bottom up. So this is the outermost view, and this is the subview. Okay. And so what we did to help with that a little bit is we take this output that we can get by just printing the type, we parse that, and we visualize it in a tree, so that you can actually see the tree that's being created there. And so let me change that here, and perhaps just remove the debug and add the mirror here, and I will also add another large padding in there so that it works with the previews. Let's see if we can make this work. Okay, great. So now you can see here that we have this very simple tree, right? It's just the padding and the text. Okay. And this is just generated from this output of the type of the view. And once we can add a few things to make it a little bit more complicated, then you will immediately see things that are happening here. So for example, you can say background color.blue or something like that. And now we can see, okay, the topmost view here is the background, because we are parsing this bottom up, right? So we start reading here. And then the background has two subviews, a primary subview, which is the padding, and then the text, and a secondary subview, which is drawn in the background, which is the color in this case. Right? So this is basically how we start building up the understanding, or how also we back then started to build up our understanding of what's happening here behind the scenes by looking at these types, translating them into the trees that we are actually building up. And maybe just to add one level of or different kind of syntax here, if we would say we have an H stack here, and we put this inside, and perhaps let me put two subviews here, and then we say hello world, something like that. And let me fix my indenting. Okay, so now you can see that the H stack in the diagram here is also it has two subviews, right? So it's the super view of these two text views, but the syntax is very different. So here we have this view builder closure in the H stack, and everything that's within this view builder closure is a subview of the H stack. So now to parse out the view tree of this piece of code in your mind, you have to start reading from the outside in, so, or in other words, from the bottom up, right? You read, okay, background is the topmost view. Then the subview is padding. Then the subview is HDAC. And then the HDAC subviews are these two things within the closure, right? So it's not very intuitive, but I think it's very important to play around with this so that you get this sense of how SwiftUI builds up these trees. That's how we always start building this up also in our workshops. We start out with a good understanding, or we try to present people a good understanding of how they can translate this code you write into trees, because that's really important for everything else in SwiftUI.
Okay.
Chris, do you want to expand on that? Or
yes, I can share some other stuff.
Yes, let me stop the sharing here.
Unless you have any questions up until here.
Oh yeah, sure. Just interrupt us anytime.
Okay. This tool is of ViewMirror. It's developed by you, or
yes, it's
yes.
So it literally, as Florian mentioned, it takes the printed type and it parses that. It's very ugly code, and then it simplifies that a bit.
Great.
Yes.
To understand the hierarchy of the view in SwiftUI.
Yeah.
Yes. So let's see where to get started. So maybe one of the reasons also to explain to the people who are listening is why we're talking about animations is also we recently talked about this at conferences, and maybe we can show some of the examples from there as well. So one of the things you can build, for example, in SwiftUI fairly easily is something like a toggle, where we can do like a capsule, for example, and this will be very big. Give this a frame that's maybe 180 by 100, and then I'll add some padding here as well to the preview, just so we have a bit more space to work with. We can fill this with, we could fill it with green, for example, and then it's more like a toggle that's on. Or we could fill it with a gray, so we could say color white 0.2. This is more the off state. And then we can do an overlay here. So we can put a circle inside, fill it with white. And so this is almost like a big toggle, right? Like maybe add some padding here. And then in this overlay, we can align the circle. So we could do it leading, or we could do it trailing. Maybe this is clear to see. If it's green, let me change that. So now you can see that it's almost like a toggle. And of course we want to change this and animate this. And this is, I think, where it also starts to make sense what Florian shows there with the trees, right? Like how that ties into animation. So let's make it animated. We'll add a state property and say is on equals false. And then here we'll say, well, we'll fill it, if it's on, we'll fill it with green. Otherwise that color white 0.2. And then the same for the alignment. If it's on, then we want it to be trailing aligned, otherwise leading aligned.
Okay.
Double alignment here. This should be is on. Okay, let's see if this compiles. And now we need some way to make this interactive. I'll add a tap gesture just to make it work. This doesn't have any accessibility, but it's just a quick way to toggle the Boolean. So we can see that it toggles between the two states, and it's not animating. And I think this is a really important a moment almost, right? So the toggle works, but it's not animating. And so what does it mean to animate? On the screen, our computer screen is drawing, 120 times per second or 60 times per second, or at whatever display rate you have, refresh rate you have your display set. The only thing we could do is draw the intermediate frames, and then it looks like an animation. And that's exactly what happens, right? Like when we play a movie on screen, it's just displaying a lot of images in sequence. And to make it feel like an animation, we need to show the intermediate states. And so, for example, this green needs to change to gray over the duration of, let's say, 1 second, if our animation takes 1 second. and the position needs to move from this trailing edge to the leading edge over the duration of 1 second. And what does that mean, to move and to fade? And so what you would do in like more technical terms is you would interpolate between the two values. So you would say, okay, let's say my end position is 100 and my start position is 25. Then for the duration of this 1 second, I want to find all these values in between.
Yes.
And that's what the dot animation modifier will do for us. So if we say dot animation default value is on, then we get our animation.
Yes.
Right? And it's almost magical. And so what happens here is that it interpolates the green color, it interpolates the position of the circle, and the combination of that makes it feel like an animation. And now let me share a different, or the same example visualized in a different way. So here, let's see if we can pull this up. So here we have that same example with a view tree on the right, or actually a render tree, where it says, well, we have our isOn boolean, we have a tap gesture, we have our dot animation. Can make it a little bigger. We have our dot animation, we have a frame modifier, the overlay, and then here there's a tuple view in between with the two children. The capsule as the background, and then the padding with the padded circle as the top. And so if we go back to the start of the previous animation, we can actually step through the tree and see what happens. So the isOn changes to false. And then SwiftUI will start updating our views. And you can see there's like a very light border here around the toggle example. It's currently updating that toggle example view. And it starts updating the tap gesture. And the tap gesture starts updating its child, the dot animation. And you can also see there's like this tiny little icon over here in between the tap gesture and the animation. And that's the current transaction. Every state change in SwiftUI has an associated transaction. And the transaction contains information about the state change. For example, it contains the current animation or the animation curve, and it's empty now. And now we're going to hit our dot animation. The value changes from true to false. And so SwiftUI now knows, okay, I need to animate my subtree. And so now our current transaction has this animation attached, right? And so SwiftUI will now animate every single property that changes in the subtree. It's not quite the truth, but it's almost the truth. So it hits the frame, and the frame didn't change. It hits the overlay, and it's actually now leading. It's going to be leading aligned, and SwiftUI does not animate the alignment property for us. Likewise, if we would have changed the width or the height of the frame above, it would not animate those properties. What happens is, in case of the frame or the alignment, this will change how the leaf nodes are laid out. So the leaf nodes in this case are the capsule and the circle. So let's continue.
Okay.
We hit our capsule node, and SwiftUI starts updating. None of the position stuff changes, but the fill color will change. So we have an animation here now from green to, it's hard to see, to a dark gray over 0.3 seconds. Yes. And then it hits the padding node. Nothing changes there. It hits a circle. And for the circle, it's actually only the X position that will change. And so now both of these properties have an animation attached. How this is actually implemented under the hood, we have no idea. But this is our mental model.
Okay.
And so SwiftUI will now, over time, go from this old X position to the new X position, and from this old color to the new color. And you can see here it's sort of this smooth, this ease in, ease out curve. And we can actually look at the timeline here. So if we go forward in time, for example, we're now at the beginning of the last animation, we can actually go forward in time. And there's a few things happening. So if we look at the preview, we can actually see these intermediate steps, right, as I drag through the timeline.
Like frames, that's what's created and during the duration. Yes.
Yes, and so if you look at the render tree on the right, you can see that, for example, halfway through, this animation is also halfway through, right? And so the color is sort of in between green and gray. And I think having this sort of way to look at the animations that really helped us a lot. Like having the trees there and having the examples there that really helped us understand stuff.
Yes, I think it's important to maybe to have this knowledge about the hierarchy of elements in the animation and how things work, and the difference. When I watch this, I think, okay, this is the basic animation. It's kind of what we call basic animation, but for the other type of animation, spring animation and other style of, there is a little bit some difference between this and between this kind of animation. And with your tools like this, you can find maybe the difference, and you have all the information about all the property of all the component in your animation, which is basic animation. Imagine much complicated animation, which we have maybe other component, etc. I think it may be very important to have this kind of tools to understand how things work under the hood. Maybe
Yeah, it would be really nice. Like this tool that we just show here is it's a lot of smoke and mirrors, so it works for a few specific examples, and it is interactive and everything, but it only works for a very tiny subset of SwiftUI and not even correctly. And so it would be nice if this if something like this would ever get integrated into SwiftUI. I think it could be very helpful to understand what's happening. But I do think also that in sort of a real application, this tree is actually probably a graph. That's why the underlying framework is called the attribute graph. And even for tiny examples, the attribute graph gets really big. And so it's probably not the easiest thing to build and design.
Okay. Yes. Great demo from your side about basic of Swift animation and how we can understand under the hood how it works. It's very important not only for Swift animation but for basics of SwiftUI, because we use some modifiers, some animation, but we didn't understand how things work. That when we make padding, we create another view, another modifier, etc. And with your box thinking SwiftUI, I think that people should maybe understand more how SwiftUI create component and animations.
Yes.
Very important thing about. Okay, Florian.
Maybe.
Yeah. Yes.
So I just wanted to add that this is because you mentioned before the implicit and the explicit animations.
Yes.
Right?
Yes.
And I think that also plays into what we showed about the view trees and about the diagram that Chris just showed, is that you have an idea where do you place this modifier really makes a difference, right? Or sometimes it makes a difference and sometimes it doesn't, and why, and then what about using a with animation or a dot animation, and all this makes more sense if you can reason based on the view hierarchy, basically, right?
Yes.
So if you, for example, if you have multiple dot animations in your code, then you can see, just as Chris explained, right, each state change is wrapped in a transaction, and a transaction carries the information about the current animation. And if you say dot animation, this is basically just a shorthand for dot with transaction, not with transaction. It's just called dot transaction.
Yeah.
It's with transaction.
No, dot transaction. Yes.
Dot transaction, right? And then within there, you just set the animation of the transaction to whatever you want. And dot animation is basically, it's not entirely true anymore because you have this value parameter, but it's shorthand for that. And then you can reason about what's happening if I have multiple dot animations, right? Because you see where they are in the view hierarchy, and that each animation will override the previous one. And then you can see what properties will be affected, because you can see in the tree where are the properties that are actually being animated in the end. And that hopefully helps if you deal with that level of detail basically more often to develop a better intuition of how the entire system behaves.
Yes.
Great. Thank you, Florian. There is an important thing from especially when I have what we call to react animation to data, especially when we called an API, the reaction of the animation, and what kind of good architecture that we could have, maybe state-driven uh, data flow, if you can say it, if you can say it, and how animation should be agnostic of asynchronous calls, something like that, or how to react. Especially, we have a question of performance with asynchronous code, etc. That may take time. The example of the Waze application or the Google Maps application, that we have real-time data that come from the server, etc., and how animation react to this. What kind, with your experience, how you can see that SwiftUI animation, it's well developed, there is a great conception about how to react to synchronous code and call to API, something like that.
So SwiftUI Animation doesn't care where the changes are coming from.
Okay.
If you want to, like all your SwiftUI views, I think now run on a main actor, if I'm not mistaken. Like everything runs on a main actor now. They changed the protocol there, and so all of that code will run in a main actor. The only exception where you could run something off of the main actor is with animation, and you can put that anywhere. And at least I'm pretty sure. Now I'm starting to doubt myself, but I'm pretty sure you can run it anywhere you want, and so that will just append to the current transaction or open up a new transaction, put the state changes inside and close the transaction, and so that could be done with any architecture. So the architecture doesn't care at all, and the only thing maybe that's slightly tricky is if you have a changing model and you want to animate to that, you need to take into account these view trees. So what Florian showed was sort of, we call that the view tree. It's the struct values. What I showed was something that's persistent, right? That we saw that the animation stayed in the render tree for a while. And to us, these are two different kinds of trees. The render tree is more like the UI view tree. It's persistent over time. It stays in memory. And the view tree is used to update that render tree. And when you deal with changing model data, you need to be considerate about which views you want to keep in memory or which views you want to recreate. And this is very much like in UIKit, right? Like, do you want to create a new UI view or do you want to update an existing ones?
Yes.
And when animations come into play, if you recreate a view and not update it, that means that any animation is lost.
Okay.
And if you want to animate like over time and keep animating and add to that maybe, then you need to make sure that your views stay around and not get recreated. And you can also animate the creation or the deletion of a view in the render tree. So much like an insert subview or remove subview, but that's called a transition. So that's the animation that runs as the view gets inserted or removed. And I think it might still be hard to work with in practice, but I think it really helps to get like fundamental understanding there before trying to fiddle with it. So exactly what Florian mentioned, like you have to understand how the code translates into trees. And then one thing we didn't really talk about specifically how that works is how then these trees sort of persist and when do nodes get recreated? When do they stay around? How does that work? And
I think there's actually a pretty simple heuristic for that, right? Or I think you can look at your code, and so for example, Chris showed this example with the color of the capsule,
Okay.
and this is just a ternary operator within the fill modifier. So when you have code like this, where you say padding is on 100, else 50, something like that. These typical patterns where you have ternary operators for parameters of views or view modifiers. Then the basic structure of your tree stays intact, basically, right? So you still have the exact same views after the state change than you had before.
Okay.
And if you have things in your views like if statements, switch statements, if lets, these kind of things, branches, and you switch with a state change you want to animate, you switch from one branch to the other, then now you start removing views from the render tree and inserting new ones. And then you are basically in the land of transitions when you want to animate that. It's not a simple property animation anymore, because the SwiftUI, if you switch from one if branch or from the if branch to the else branch, it's a new view. I'm not sure. He's back. Perfect.
I'm back.
Yes.
So that's the distinction you have to make. Like if you just change properties by using ternary operators in the parameters of the modifiers of views, then you will actually have these property animations that Chris showed, right? The background color or the position of the views, stuff like that. If you get into the land of branches, like if, else, switch, and so on, then you actually make real changes to what views are currently in the render tree. And then things get a little bit more complicated, because then these views will be transitioned in and out, basically, and it's a little bit different thing than the other animations.
Yeah, and I think maybe to add to this, the keyword, if people are interested in this, is to search for identity of views, and specifically structural identity. There's like a whole I don't know, area that you can read into. There's a whole lot of material on this, but those are the keywords, like structural identity. And I think there are even some good WWDC sessions about this. We can share some links later for the show notes.
Yes. And they come maybe to my next question about what best we speak about what we call testing approach in Swift animation, and you have mentioned in your example using tree structure, etc., to understand. But if you have another approach to testing animation, because I think it's very, very difficult to testing this kind of things. What do you think about some approach? You have shared the tree structure. It's very important, but maybe you have some other things.
Do you want to go first, Florian?
Okay.
Well, if you think about that, so maybe just to clarify what you mean. Like, you mean testing in terms of being able to do that automatically, to make sure that your animation stays as you originally programmed it, or what kind of testing are you?
Yes,
okay.
something that we maybe we call the integration testing, etc., to verify that your animation works properly, or unit testing your animation after, and to be sure that your animation work properly, and no one else can maybe drop or cancel the behavior of your animation. Maybe there is like snapshot testing, something like that.
Yeah. So maybe one thing that comes to mind is, and that it's probably more of a rare exception that you can imply that, but if you write your own animations in the sense of that you write your own custom animatable view, for example, or custom animatable view modifier, where you basically create your animations based on a simple value being interpolated from 0 to 1 or whatever it is, right? And then you build your own stuff on top of that. That is something you can test pretty easily, right? Because that is code you can just feed in these values yourself, and you can pull that code out of your views, even, so that you have simple structs where you can feed in values and see if the output is correct. As soon as this is integrated into the normal, like if you want to test this integrated into real views, I think this is very difficult to do. I mean, this is you would have to do kind of snapshot testing per frame or something like that.
Yes.
Yeah.
Chris, do you have ideas?
So we did a few episodes on this. So I just pulled up episode 405 called Debugging Animations on Swift Talk.
Okay.
Yeah.
And there it's free, by the way, so people don't have to subscribe to watch it. And you can also just read the transcript instead of looking at this video. But what we do there is we basically create a custom timing curve. So not an ease in out one, not a linear one, but we create our own timing curve, and then always have like a fixed progress. For example, a progress of 0.1 or a progress of 0.2. And that way you can sort of use that to create a snapshot of the view in time with a specific progress. And so that's maybe one way to drive those snapshot tests. Like to also be completely open, we have not really tested these animations. So this is just a sort of almost like a hack to test stuff like by having a Mac app with a slider or something, or an iOS app with a slider. It's not a unit test or anything like that. Another thing we did is you can also relatively easily do this for keyframe animations, which use a different subsystem. So you can drive a keyframe animation using a timeline view and then also make that interactive so that you can go back in time. And my current best animation debugging technique, which I'm very proud of, is to create a screen recording with QuickTime and then play it back frame by frame. So it's super low tech.
Yes.
But and I think it's quite hard. I don't have a good story there, and I also don't really know how to, like, a lot of the animations, if they would be wrong, you might not even see it in a snapshot test, but it's just as a timing curve feels wrong. Like any experienced designer will be able to tell you. I sometimes will, but often not. And just by looking at the animation, you, like, depending on the experience you have, you might not even notice it's wrong or it's So I don't have a good answer, actually.
No problem. It's just a question from my mindset. My mind, I think about how to test, etc. And maybe it's a topic that you can explore, and also the community, and to test Swift animation. And let's come to another section in our episode. Speak about the future of SwiftUI animation. Especially what kind of improvement or that you hope to see in the SwiftUI animation API, and in the next version. I don't know, because it come with SwiftUI evolution, but what kind of improvement or feature that you may want to see instead of the tree, the structure, the hierarchy. I think that's I think it's mandatory to understand the SwiftUI animation. But what kind of other improvement that you want to see in the SwiftUI animation API, especially?
So I think last year we got a lot of, I don't know, it's not meant to be derogatory somehow, but low-hanging fruits in an animation system, right? Like face animators and keyframe animations and stuff like that that are convenient, but that we actually were able to do before as well, right? These kind of animations use much more work. You have to build it yourself, but you can build it yourself. And we got some nicer APIs around these things. Maybe one thing that is still difficult, or where it's also very hard to build this for yourself, is if you want to apply like different animations to different things in like for the same state change, right? So that because the transaction always carries one animation. So that is I think still a problem that is hard to solve.
We saw this with the trees, right? Like, so if, we had, for example, for the capsule, we had the X, the Y, the width, the height, and the fill. And it's really hard in a single state change to only, or I don't think it's even possible with a single state change to animate the X, but not the Y. Or animate the X, but not the fill.
Okay.
Sorry to interrupt you, Florian.
Yeah. Yeah, no, that's exactly what I meant. So that I think there are some things that are not easy to just fill in by building your own animatable view modifier or something like that. Other than that, I think with the updates from last year, things are looking pretty good by now. So especially with keyframe animations, that just makes things a lot easier. That was a lot of work, or perhaps also a lot of math. You know, if you are not totally into this world of animation math, then
mathematics.
yeah, that makes it much easier. So it wasn't kind of a revolutionary new thing you could do, but it makes it much simpler. Yeah, I don't know. What else do we want to do with SwiftUI Animations?
I think maybe, well, you think I can add one more thing is that, so we didn't talk too much about how keyframe animations work, but keyframe animations basically says like, I have this value and here are my keyframes, like my points in time, and I'm going to animate that value over time. And then that value is used to drive your view layout, view, the views. And so you're animating the value. And whereas with the animations we just saw, the regular animations in SwiftUI, you animate properties of the views. And these are two different things. For example, this sort of breaks when you have a regular animation and you're using match geometry effect and you do this hero animation and all is great. But then you want to use that match geometry effect inside a keyframe animation, but you cannot make a match geometry effect like with a progress of 0.5. It doesn't have parameters like that. And so there's a bunch of these modifiers that you cannot really drive from keyframe animations. And so that's maybe one area. Like, I don't envy the SwiftUI people because it doesn't sound like an easy problem to solve if it's solvable. But that's maybe one area I'd be interested in seeing some improvements.
Yes.
Another area that comes to mind that is more like a practical one is things that we had in UIKit. So, for example, navigation transitions. And there was this elaborate framework where you could do everything you wanted for navigation changes, and these kind of things are on this level of functionality. There are still things missing in SwiftUI. So I think there's still a lot of work to be done on a higher level as well. So there are some low-level things like Chris just mentioned, right? Some things that would be nice if you could make them work, but also just higher-level APIs that are still lacking, like navigation transitions.
Yes. I think from your point of view, that Swift animation, it's like Mater now. And with the improvement in SwiftUI, there is a lot of things that was improved by Apple and by developers around this. I think from 2011, if 2019, the operation of SwiftUI, and by the time there is a lot of improvement, and we can say that that SwiftUI animation is Mater now, and all the improvement. Maybe there is not a great improvement that we can find in the next version of SwiftUI, and this is a good thing that people can begin using SwiftUI animation in complex application. Great. That come to my last question. It's about your advices to developers, not only for SwiftUI animation, but the community of developers around that maybe see us or listen to us now. They try to have some advices from your after this years of developing and giving great content to the community. What kind of devices, especially for not only junior developers, but for people that they think they are senior, etc. And what kind of advices that you can have to them?
So let me try to start. One thing that has worked for us, I think, very well over the years in terms of us two pairing up, is that we come with three different personality traits in terms of how easy it is for us to get started with new things and to finish off things we started. So for me, it's much more like I'm the one who is better at finishing things, sticking with things, and not getting distracted with new things. And
Okay.
Chris is much better in jumping into
Did you see the
jumping into
squirrel?
new things.
Yes.
Chris is just much better at jumping onto new things and just he doesn't have the same kind of hesitation that like I need more time for that, you know. And so just by observing this difference between us, and I think there's something to be said about the issue with new things, like, I don't know, be it Swift, be it SwiftUI. There's always these huge debates in the community, and some
Okay.
developers have very strong opinions. This is the
Mm.
best thing ever, or this is the worst thing ever. And I think for me, it's more, it's for me personally, it's always more of a pragmatic thing,
Mm.
So there's this new thing, and then I look at Chris, how he jumps onto that and gets curious about that and starts experimenting with that. And I'm still more on the fence, I'm still watching this from the distance. And that's something I really learned from Chris over the years to that it's really a good thing. It's a good quality, right? To be curious about that. And perhaps also you can just withhold your judgment whether this is good or bad. It's just something new that is there and that is interesting, perhaps, right? And perhaps you can learn something new by examining it. And so I think this kind of mindset of just looking at new things with a curious mind, and investigating how this works is something that is very valuable in terms of getting further in or getting better, because you develop a deeper understanding. And if you, and I think it's a good thing if you can stay away from judging things too harshly, right?
Mm.
Or at all, like not jumping to conclusions or to harsh judgments immediately because of your past experience or your past history with whatever things you used, because even if the thing that perhaps in the end it's bad, doesn't help you, but maybe there are still very interesting lessons by looking at it and examining it. So that's definitely something that I got to observe a lot over the years, how Chris deals with new things. And I think that is a very good thing if you want to become better as a developer.
Okay. Great.
Thank you.
You're welcome.
Yeah, I mean, it's the other way around as well, right? Like I told the story in the beginning how I thought like I got hired as the expert iOS guy, right? And Florian would come back to me with all these questions and not just the questions, but also the answers. And I was not as curious about things at that time, maybe. And so I was just also mainly focused. Like, I was focused on getting the project done, and Florian was focused on learning iOS. And so that mix really helped. And I don't know, maybe it's so personal, right? Like to give advice to I think it's always a personal question, like who are you giving advice to? I can share what I think has worked well for me, but maybe it's also just random things. I don't know. For me, I feel like explaining stuff really helped me because when I want to explain it, I want to really have the feeling I understand stuff. And so if I commit to writing an article or even a book or give a presentation, I want to dive into stuff and I want to really understand it and exactly understand how it works. And sort of getting that pressure helps me investigate and helps me stay curious. And yeah, I do think I also had to learn, as Florian mentioned, to withhold judgment and also not to get too emotionally attached. So
Okay.
when Swift came out, the SwiftUI evolution thing was big, and I participated a bit in that, but I found the environment not really good for me. And I noticed that like the moment I got too involved in changing Swift, it just that just didn't work for me at all, because I had my opinions and all of that, and now I feel like our role, or my role, I don't know, is more sort of an observer. We just look at what comes out, and some of the stuff is sort of naturally easy to understand for us because of our backgrounds, and other stuff is really hard. For example, when Swift came out, it was pretty easy for me coming from Haskell, because it was a lot of similar stuff, and then also the Objective-C background. Likewise, when SwiftUI came out, I think for both of us it was relatively easy, because we had just implemented, like, ported the Elm architecture and other declarative systems, and experimented a whole lot with that. So it was sort of natural. But now we are struggling quite hard with concurrency. This is, for I think both of us, something we don't know that much about, and especially in the form it's in Swift now, and so there it's definitely like a harder struggle. And what we try to do is actually build complicated stuff with it, and then sort of go back and try to understand the principles. And I think at whatever level you are, trying to challenge yourself a little bit, and then going back and see, like, what did I learn from this? Maybe one way to do that is you can go back by just reflecting. You could also go back by trying to write a small blog post, give a talk to colleagues, or at a conference or a local meetup or something like that. That's one strategy that worked really well. And everybody's different there, right? Like, so some people have no issue with giving a talk, and other people stress out about it, and then there's probably a different way for them to do that.
Yeah. I think there are different ways, but how you do that in practice for yourself in the end. But I think the first step is always that you have to notice if the thing you are writing at the moment, the code you are writing, do you understand it, or do you just get something done? And it's not. If you have a job, you're working on a project and you have a deadline, there's nothing wrong with getting things done, but I think it's still important to notice in your back of your mind, what are the things here that you don't actually fully understand what you're doing, right? Because that always leaves these traces you can go back to, or these points where you remember there's something I didn't fully understand, and perhaps then you encounter it next time and decide to look into it a bit further. And there are always time limitations on that, but I think that's the first step, right? You need to notice the things you actually understand or don't understand.
I think once you have like a few topics that you really deeply understand, that really keeps paying off. So in hindsight, I wish I would have spent much more time learning Git. I use Git every day. I use it for everything. And basically, anytime I invest in getting better at Git helps me. And I think it's the same with SwiftUI. And I wish I'd done that more with UIKit and with and core animation and those technologies that keep coming back every single time. And I think in hindsight, it's sort of easy to know where you should have done that. But but everybody's different, right? Like, so
yes, it depends of the human being, human, and this capability, and how they think about learning and progress in his life. Thank you, Florian and Chris. It was a very special episode with you. And this is the last episode. I try to thank also all the guests that was with us. I think we have now 17 episodes in the Swift Academy podcast with people around the world. I think from France, from my country Tunisia, from India, from Greece, from Germany, from Netherlands, from United States of America, from also Canada, with different topics: security, macro, clean architectures, and also testing. We have some great developers that come with us, like John Reed, John Reed, Daniel Stannenberg, and other developers that come also with us. Bogdan with his famous refactoring coding, with 3 hours of refactoring coding this episode. I try to thank you everyone, not person that I mentioned, and I think it's for me it's special experience. This is my first season in the Swift Academy podcast. I don't know, maybe I don't have another season from the Swift Academy podcast. I will think with my especially with my wife if I have time to to do that, because it take a lot of time to prepare things, to choose and to contact great developers around the world, and to prepare also, especially to prepare questions and make some work about it. I will discuss with the family about that, but it was for me a great experience. It was a pleasure for me to have you, Florian and Chris, for this last episode. Maybe we have some other episode in the next season, if you have next season. And that's all for me. And thank you everyone that listen or watch us. And thank you. Bye. Bye,
Thank
Chris.
you. Thanks, Waleed.
Thanks for having us. Bye.